Okay, so I'm Zach.
I'm Tim.
And I'm Nick.
And we looked at linear transformation in relation to neural networks.
The first type of neural network we looked at was a biological neural network. Biological neural networks were the first type, and they're primarily found in the brain, in neurons. The process is fairly simple. The electrical pulse passes from neuron to neuron, and they enter through dendrites. Dendrites, in this case, we can think of as our input matrix. They take in the initial values, and then they're passed through the cell body in the axon, which in this case can then be thought of as the transformation matrix. Then finally, they leave the neuron from the axon terminals, which then can be thought of as our output matrix. Here it is simplified in a nice image here. We take the input in, and then there's a bias. The bias is what allows us to shift the activation function by adding a constant. Bias in neural networks can be thought of as analogous to the role of a constant in a linear function, whereby the line is effectively transposed by the constant value. Then once the bias is applied, we can then output the bias. This is a basic neural network. What we can do is we can write this in such a way of a matrix. So the first column, called the input layer, can then be written as just our basic input matrix. Then a neural network has what's called a series of hidden layers. The hidden layers are what takes the input matrix and then manipulates them. In this case, these will be our transformation matrices. Once the manipulation by the hidden layers is done, we then output the matrix, which then is just a simple output matrix.
Okay, so in relation to the mathematical side of linear transformations, we're all familiar with an input vector being v. And so I have some numbers here. We have 2, 3, and 4. And then there's some transformation matrix AT that actually does some sort of transformation and manipulates this vector. And once that manipulation is done, we have a post-manipulation vector called W. We usually refer to this in terms of linear transformation as the image, with our input being the pre-image. And so in relation to neural networks and neurons, we have a very similar format where you can have different inputs like our initial vectors, so 2, 3, and 4. And another transformation is put onto these values. So you can see here that our columns from our transformation matrix is the different transformation done onto the individual values. So these hidden values are going to manipulate our data that's input, and it's going to be output with another vector. And so an example of an application of this is facial recognition software. So you input maybe different pictures of faces or data with different faces. Different manipulations are done onto them to find different patterns or maybe different quantitative values. So say the -1 maybe is whether they have blue eyes or green eyes. And then 13 is maybe the shape of their nose or the shape of their lips. And so you can see that we input different pictures and we get a very easy to understand output.
Yeah, so like Zach said, there's lots of applications, some of which are education, predicting stock markets, and medical. So something for medical is that we can predict diseases. So we have our symptoms, like symptom 1, 2, 3. They could be like a cough, a runny nose, a sore throat, anything like that. And then the hidden layers are finding relationships between them that link them to common diseases. So this could be used to diagnose people rapidly and with accuracy, like for COVID or something like that.
Yeah, so that was our presentation. I hope you guys learned more about neural networks and linear transformation.